Hello class, welcome back to the Chong channel. Right now we're going to look at two examples and how to factor completely. So the first question here, we have to factor this completely. Now the first thing, anytime you need to factor, you should be asking yourself these questions. First, is it X factor? So if you remember from all the videos before, in order to do X factor, we need to have a coefficient of 1. But over here, we do not have a coefficient of 1, so it is not X factor. Now let's look at the second question. Is it a difference of perfect squares? Well, first of all, this is not even a subtraction sign, so it cannot be a difference of perfect squares, so we cross that out. And so finally, we ask ourselves, is it GCF? And it is, because all the terms have a common factor of 10. So our GCF right now is 10. All of these numbers are divisible by 10. Now here we see n squared, here we see n, but do we see n here? No. So there is no n outside as a GCF. Okay, so the next part, we're doing the distributive property. 10 times what term gives you 10n squared? Well, I already have the 10, and so we're missing the n squared. Next, 10 times what term gives you positive 100n? And that is positive 10n. 10 times what term gives you positive 250? And that's positive 25. Now, if you were to leave your answer like this, you would get it wrong on the regions, because if you're factoring completely, that means you have to keep factoring until you cannot factor anymore. So we keep the 10 outside, and so we look at this parentheses, and then you keep going to ask yourself the same question. First, is it X factor? Yes, it is X factor. X factor is always in the format of n squared, n number, and the coefficient is 1. So we set up the X factor. It's going to be last, top, and that's our product. Middle, bottom, sum. Middle, bottom, sum. So once again, we're going to just forget about the sign for now, whether it's positive or negative, we don't care. We're going to list all the factors starting from 1. So 1 times 25 is 25. 2 doesn't work, 3 doesn't work, 4 doesn't work, and then we have 5. So how do you know you're done with your list of numbers? When the numbers repeat, or after that last number you wrote down, if the numbers continue to the top. Alright, so which of these pairs adds or subtracts to give you that 10? And the only choice here is 5 and 5. Now, you got to focus on the sign now. Sum is like little brother. Little brother follows the sign of big brother. But which of these numbers is bigger? Well, they're both the same, so they're both going to be positive. So double check in your calculator. 5 times 5 is 25. Yep. 5 plus 5 is 10. Yep, it works out. So now we set up the factors. N times n is n squared. And then we got the plus 5 and the plus 5. So in this situation, when we needed to factor this quadratic expression or this polynomial, it ended up as 3 factors: the 10, the n plus 5, and the n plus 5. Alright, now let's look at the next question. So here we have to factor this completely. So the first question you ask yourself, is it an X factor with a coefficient of 1? Well, this is not even a coefficient of 1, and this is not X factor. It is not in the format of p squared, p number. So it's not X factor. Then the next question you ask yourself, is it a difference? Well, it is a difference, but is it a perfect square? Well, 10 is not even a perfect square. Once one term is not a perfect square, the whole thing is not a difference of perfect square. So that doesn't work. And then the next question you ask yourself, is this GCF? And while 10 and 1960, they're both divisible by 10. So that's a GCF. Here we have p to the third, so that means p times p times p. And here we have p. What was the common number of p's we have? 1p. So the GCF here is 10p. Now we do the distributive property. 10p times what term gives you 10p to the third? Well, we already have the 10. We have a p. I want 3 of them, so I need 2 more. Next part, 10 times what term gives you negative 1960? Well, 10 times negative 196 is negative 1960. And we already mentioned the p, so this p is taken care of. Now, once again, you cannot leave your answers like this. We have to factor completely. Factor completely means keep factoring until you cannot factor anymore. So let's leave the 10p outside. And in this parentheses, we're going to go through the same list. Is it x factor? No, it's not in the format of p squared p number, so it's not x factor. Next, is it a difference? Yes. And is each term a perfect square? Yes. So you set up the 2 sets of parentheses. What perfectly the same multiplied to give you p squared, and that's p. What perfectly the same multiplied to give you 196? Well, let's say you didn't know that mentally. You just have to do the square root of whatever number you're trying to figure out. So the square root of 196, and it's equal to 4, which means 196 is a perfect square. So we have 14 times 14 is 196. Now, if you notice, they're perfectly the same. The only difference is the sign in between, because positive times negative is negative. And so if you look at each term, it cannot be factored anymore. So now we know we are factored this completely. So how many terms multiplied to give us our original polynomial, our original algebraic expression? 1, 2, 3. I hope that helped. Bye-bye.